is analogy making in the visual domain possible using traditional or NARS type reasoning? If not, what's missing?
Yeah, I saw that. I didn't reply immediately just because I'm afraid I'm going to take all the time for this discussion on that topic.
Well, I think in some way, you know, some of Kai-Uwe's claims about analogy making of humans actually hits him against you. Because essentially you've said anything can be done with a NARS-like approach. Or at least I haven't heard you say X is not possible with a NARS-like approach ever.
Oh, yes, there are several things impossible.
No, my claim was more or less with the classical types I presented, it's not possible. I would consider NARS as not a classical type of these reasoning things that were mentioned like reduction.
Okay.
It's a probabilistic, confidence-based, but still logic and non-axiomatic reasoning system, which is, I would in any case call absolutely non-standard.
Yeah.
It's, and therefore I think there would be, so if P is claiming he can do everything with NARS, what I would expect, I'm perfectly fine with that. And if he's saying, well, there are some gaps here, I'm also perfectly fine. So I think there's no clash.
Yeah.
But my focus was really on this classical types.
Actually, according to my personal judgment, his approach actually is one of the closest compared to mine in the current AGI, say, community. You see, I completely agree with his criticism toward the traditional reasoning, learning, and so on. And both of us have a very strong motivation, to set up a new standard for rationality. And we have the same background from cognitive science. Actually, we came from the same university, okay? So it should not be a surprise. But on the other hand, our difference, what he wants to do is very similar to what I want to do, even though we describe it in different language. Our difference is much more technical compared to my difference with other people. Okay, like for example, Ben Gotto and the others. Both of us are doing logic-based system and try to use one technology to cover as big territory as possible. I also will agree on that. So the key difference is actually the selection of the logic. If we really want to set up a debate between the two of us, I guess that will be a debate between a multi-value term logic against a binary valued predicate logic, and which framework between the two is better for the job, even though they are not exactly have the same job, but very similar, very similar. You see, I can actually say everything that NARS is doing is analogy in a very broad sense. I actually make that claim in one of the papers. Okay? Yeah, now very broad sense. And also I fully understand the importance of, say, creativity and the concept blending, even though I don't like the phrase concept blending that much. You see, it's more like how to actually do it. So if we really have the time, for this difference, we should actually sit down one by one, go through, say, a couple of concrete examples to see what your system can do better and what my system can do better. So in general, if I have to challenge you, I will say, you will see, you really need a binary, multi-valued logic. Binary logic is not enough for this job. Also, you will see that term logic will do better than predicate logic. But I know that it's not something I can argue for with a few sentences. Yeah, I guess that's where our difference really is.
Right. So you're a proponent of two-valued logic? Is that correct?
Well,
I did not take that away from your talk at all, but
it depends on the perspective. So clearly the underlying framework is based, first of all, on a many-sorted first-order classical logic input, first of all. And the computations that are going, so computing the generalizations, for example, are also in a classical logic style, because there was defined. Now clearly the system is, from another perspective, not binary, because an analogy system computes hypotheses. And in our case, in the original version of it, it was not a probability that was assigned, it was a cost function that somehow just orders the possible analogical relations according to a list, and the one with the lowest cost is on top, and then there are other alternatives. That is not so different from the structure mapping engine, which is doing very similar thing by Can-Forbes. So in principle, what these people are doing is also they compute potential candidates or hypotheses for analogical relations, and according to, again, a cost function in their system, they order them. So in this sense, it's not binary, because there's no true or false. There are candidates that can be computed, and then to which extent they can be applied is first of all dependent on the model, and to which extent the whole thing becomes inconsistent is the parameter tuning that was a little bit mentioned, or that was actually intended to be mentioned in this challenge 3 thing, where you do the inductive refinement. Which parameters need to have which values in order to keep a consistent theory, and where something goes wrong. And in this sense, it's not binary, because it's not a deduction or so. It's just a candidate hypothesis for this particular context and this particular contextualization. But again, we are not probabilistic in a sense, like P is this, or also Ben's framework is also kind of a probabilistic version, or some people from I don't know, relational learning, for example, use some kind of probabilistic logic approach. So in this sense, it's a little bit different. Actually, although it's also something very new, currently Tarek, together with Van Diekel in our institute, are working on a probabilistic version of HTTP, where it's no longer just a cost function, which makes it a little bit more fussy, but where really probabilistic reasoning, the Bayesian style, should be implemented in the system. So I converged.
Yeah, you normally you don't mention that cost thing, right? In your about this. Yeah.
So in this sense, we are relatively flexible, and analogy making, in my opinion, and this must be quite clear. Analogy making is not a deduction. It's not that you have an input and then there's a deterministic output and that is true. That no analogy engine works this way. It's kind of, well, there may be this hypothesis that models something, but there are other candidates that can establish this. And whether Juliet is the sun, the right interpretation is she's hot, or something else, depends, right? And for example, what we did one time is, in the geometry domain, we did a relatively, for our standards, a relatively large psychological evaluation in the geometry domain of geometric analogies, where the analogy, so proportional analogies A is to B as C is to D, which were considered to be ambiguous, right? So there are many possibilities. Not like an intelligence test. In an intelligence test, they have some extremely strongly preferred solutions, unique solutions, because else it wouldn't be a reasonable intelligence test. But we were trying hard to create ambiguous analogies, and then we were interested in the distribution of the results, what people did. And in total, I think there were nearly 300 subjects tested on this problem set, or some different versions of this problem set. And then you get a distribution of this. And then what you do is essentially, and this is the best of all possible worlds, you want finally somehow a system where you've given the same input, and the list somehow reflects the psychological preferences of the subject. That is essentially what you want. Whether this works all the time is another question. But that is essentially the idea. And here, clearly, there is no true or false, there is no right or wrong, there is no bivalence in a hard sense. There is an analogical relation to a certain degree in many applications. And in some, like in Raven's progressive matrices from the beginning, that is an intelligence test, a very famous one actually. Here the statistics should tell you something like 90.9% of the people who can solve it should come up with this particular solution. And everybody else that comes up with something else just don't understand the analogy. And this is something, so there are several, it comes in degrees.
But there is another issue you actually already touched. That's another thing I'm not very happy about in your current work, is semantics. It's clearly not traditional true and false.
No.
And it's a matter of degree, but it's a matter of degree of what? It's not probability either.
No.
Yeah, or you have to reinterpret probability a very different way compared to, say, the classical probability theory or statistics practice. So you need to have that.
That's true. The only thing you can do here clearly because what I presented in this one slide, that was that is clearly this is not an explicit semantics. It's a very abstract theory where you can prove that it guarantees the existence of a model theoretic semantic without specifying. The second point is, to a certain degree, that clearly what the thing can model is only if you have two input theories and you compute your generalizations, and this is now what you chose, you can give this generalization a meaning. But clearly not the probabilistic list of possible candidates, because that does not work in such a theory of institutions framework, because it's a classical model theoretic way of logic, giving meaning in a logic sense. And in this respect, it's only if you choose one particular instantiation, and for this you can give a semantics, but not for the complete computation process. But for that, you need something different, because classical model theory does not work with probabilities and with cost functions that can
Yeah, we completely agree on that point. It's just if a classical model theoretic semantics doesn't work, what I have tried is to build what I call experience-grounded semantics. Okay, to use available evidence to say what that degree is. In your case, I can understand intuitively what that cost means, but I need more detail. Also, another thing, even intuitively, I think cost may be only part of the story. There may be something else. What makes analogy tricky compared to other type of reasoning is you can almost possible to always make one thing to be similar to another one. Okay, if you push hard enough, or given any two things, they can be similar to each other in several different senses, not many. So the key is not really to find a mapping, is to make the selection among all logically possible mappings. That part I think is not very clear to me, in your system. In my system, I use things like activation spreading, that kind of thing, to control which, say, property is active, so I pick that, I ignore the others. In your system, I'm not sure if you have multiple possible mapping or analogy. Which one is selected, or is completely based on cost, or there's something else involved?
It's just based on the heuristics you use. That is the word that you put in order to get the classification. Because the cost function is defined by the heuristics.
But where are the heuristics come from?
Pardon?
Where are the heuristics?
Yeah, they fall from the blue sky, essentially. Because we tried really several things here. So, for example, for example, if you think about structure mapping, it could be the case that if you do kind of a connection graph model, so how deeply is some formula or some ground atom or whatever embedded in a connection graph makes it more important than something that is completely isolated. And you can assign costs to the embedding and the connectedness. It was actually a master thesis that was written by an exchange student from Birmingham who wrote his master thesis in our institute. And for example, this heuristics completely failed, strangely enough, because we had very high expectations for it. Completely failed, complete nonsense was the outcome. And this was actually a trial and error thing we did. So for example, the heuristic that orders the terms and formulas on the target side is just based on complexity. Start with a very simple one first and then go to more complex ones. The reason is relatively simple because if you start with a complex one, the branching factor of possibilities is way too much, and then you need someone to guide your search somehow. That's the idea. What seems to be a relatively good heuristics is just the minimization of the substitution lengths. So the shorter the substitutions, the more preferred. This seems to be an extremely good heuristics, and it's somehow something like Occam's razor somehow. Right? So the simpler something is to establish, the more preferred it is. Seems to be an extremely good heuristic. Then clearly another thing is the heuristic that calculates the coverage of the original domains, because usually the original domains are not completely covered. So you need somehow a measure, so to which extent is your analogy covering a maximum of your domains. And then you have a trade-off, because this can contradict, clearly in any case contradicts with the substitution length, and then there's a trade-off where you have to balance something. And things like that, right? And clearly what you want is somehow a trade-off between a minimal substitution length, a kind of maximum coverage of the original theories. Then you can think about if you have priming factors, for example, that something is important in a particular situation, stuff like that. And then you can compute a measure. And clearly these heuristics are somehow heuristics that are, in my opinion, relatively similar to heuristics that are used, for example, in the classical AI field. So in general game playing, what was called just world knowledge in the sense of heuristics, this comes relatively close. It's a very classical AI idea. But again, we are relatively also open to this probabilistic approaches, and currently, as I said, some people are trying to do something in this direction. We will see.
I'm curious because actually analogies are a great thing to discuss in the context of AGI because it touches on so many things. But one of the things that I'd like to ask you, which is somewhat puzzling to me. Now, when we, in view of your examples, when humans make analogies like an airplane looks like a type of wave, we can actually discuss that analogy between the two of us and move our attention from various parts to other parts and discuss how is the airplane similar to a wave in its shape, and what are the main features that actually contribute to why we feel like that, or why we agree on that, and so on. And there's a tail sticking up like that. There's no such thing on the whale. And so when we do this, we go very easily between linguistic representation and the spatial representation. And if we were talking about shapes that are moving in space and changing shape, you know, it's a spatial-temporal domain and symbolic domain, and we do this very easily back and forth. And how would you do this? That's the question. How would you do this? And then I'm going to bounce that question to you.
So
Is the spatio-temporal representation in your system a special case for a special domain that, you know, boxed off somewhere as a sub-function, or what?
So in principle, I think what you are asking for is a little bit a broader question. And I think the real question you are asking is, where does the input come from? Because depending on the input, whether it's about forms, spatial representations, whether it's about whether the whale has a heart and lungs or whatever, or whether the plane has a Windows operating system as the control operating system or something else. This depends on the input, right? Because you need to give the system something, right?
Yeah.
And then clearly, depending on the input, you get different analogies. That's key.
Yeah, and it's not that sense that I'm talking about. I'm talking more about the representation of the information. You know, it's spatial-temporal in one case, and it's logical in another case. We can make arguments about spatial-temporal things, and going back and forth very easily.
Yeah,
but you know, in propositional logic, how do you represent the shape of a whale, and how do you represent that it's similar to an airplane or not? Or how similar it is to this airplane versus that airplane? I mean,
well, there's okay. Then I misunderstood your question. Okay, well, there's a lot of work actually now in the perhaps not about whales and not about whales probably, but about geometrical representation in general. Also about artifacts, for example, about I don't know, cars and fridges and tables and chairs and I don't know. And probably again the leading figure in this field is Kai-Uwe, who developed a system called Sketch, where you can just sketch some geometric entity, a car, a plane, so clearly not a picture, not on the computer vision level, but sketch something. And the system to a certain degree completely automatically generates a logical or quasi-logical representation of the thing, reflecting the structural properties of this. And clearly this has a long tradition actually, because for example, one PhD thesis in the late 90s by one of his students, Dustin, was precisely about this issue. He developed the language of perception. And this is not a logic, but an algebraic framework in order to represent such things like whales, planes. We did a little bit in this direction. So what happens here is, although it's not clearly not at all as advanced as Sketch or Corvus, although also Sketch works only in a semi-automatic way, because still, as far as I know, also in the current newest version, the user for an input needs to define kind of bounding boxes in order to generate or to identify the interesting regions. And then you can make and what we did, for example, is we used also such sketches, and then there's the system gets only the following input, like the lines essentially in an unstructured way, and then it generates interesting regions out of these lines. For example, polygons that are closed is an interesting region, whereas some polygon that is not closed is not an interesting region. And then you have regions, and then you clearly, and you can use, for example, the RCC8, that was the axiomatic system at the beginning, or a long list of axioms. You can think about, use such a calculus in order to identify the relational properties of the region. So one region is contacted another region, two regions overlap, they are externally connected, they are disconnected, things like that that are represented in this calculus, where you have an axiomatization for. And the regions are just the x's and y's you put in principle from your region detection system. And then you can do reasoning. So that is one way to do it. I don't claim that this is very well developed, and also in Coq-Sketch it's a semi-automatic thing because you cannot expect that a computer that you can draw something arbitrary and then the system understands everything. But to a certain extent it works actually. And you can make a story out of this on this logical level. This would be somehow the mapping from the spatial representation to the logical. What nobody so far as I know, really considers is to do really the computer vision part. So take, for example, a real video or a real picture of something like this, and then do the computer vision first and the pre-processing and I don't know what, and then detect it. As far as I know, nobody did this so far in the analogy field. They abstract a little bit from this level because nobody is probably an expert in computer vision. That's the simple reason. So that's the idea.
What about you, Kai?
In my case, I think the first thing is in my system, I don't hold that traditional distinction between, say, symbol and, say, sensory motor perception, that kind of thing. Because to me, that line or that distinction have a large, a major factor is the traditional way we use symbol, especially how it's handled in classical model theoretic semantics. Say that a symbol refers to something outside there. On the other hand, sensory motor is kind of like directly hooked to your sensor and actuator. So symbol need to be interpreted. Everything else naturally already have its meaning. So that then the symbol grounding problem appear. So how can you connect this to Twitter? Which is closely related to what you asked, I believe. But you see that in my system, first, the symbols, most of the symbols used in my system doesn't even get a meaning in that way. Okay, so you see that intuitively speaking, everything is in a huge graph or network. It's kind of like on the boundary of the network, you have sensory motor directly related things. Then they are going to go through a generalization process until something getting more and more and more abstract toward the center. But still, everywhere in this network, the meaning of a node is nothing but determined by its link with the other nodes. That's my semantics, basically. So in that picture, it's a matter of degree. You don't have, the symbol, where the symbol kind of get its reference, you don't have this issue anymore. A symbol is already grounded in that sense. It's grounded in the system's experience, even though it's not directly hooked to a sensor or actuator without going through, a whole bunch of multiple level of abstraction. So remember the slide I showed you have, a bunch of birds on the boundary, then you go up and you get some internal concept, then in a certain language you can say, oh, that concept is bird. But the meaning doesn't really come from that relation. It's more come from the relation of that concept with your lifetime experience. Okay, just some of them are closer to the sensory motor, some of them are more abstract.
But how is your experience with shapes represented then?
Well, again, the same thing. If you have sensory motor, which directly related to shape, if you don't have vision, that's a different story. Okay? If you have vision, then first, in the lowest level of abstraction, you directly get kind of the image in your eye. Then it get kind of like compressed or simplified or abstracted or generalized, what do you call it? Okay? You get more and more and more general, which means the same thing in my mind will correspond to not one single concrete picture, maybe a whole bunch of them, which we call, say, bird. Okay? In that sense, that thing is kind of like an abstract representation of the bird shape, even though maybe not clearly drawn in that way. Okay? But if we use a neural network terminology, wherever you see a bird, and that thing will be activated to a certain degree. or something like that. So you don't have that the traditional boundary to a clause in the first place. Does that make sense?
We should give others a chance to ask questions. Yes, that's good. Yeah.
I have a more general question. In Germany, currently, lots is going on with the word cognition. There are many chairs which use cognitive techniques to solve some problem. For example, as a co-thesis in Munich, they try to do lots of different things with cognition. And this is also the case at my university, from Aachen. We have the excellence cluster, and I am working in a group where we are dealing with self-optimizing systems. There is some hypothesis which came up that self-optimization is only possible if you have cognition in your system. And now when I built my system, which is a planner, it does the job, but then immediately somebody else is saying, okay, this is not a cognitive system. And I always have the problem that I have to defend myself. So my question is, at what point can I say my system is cognitive? What do I need? I need some perception, I need some internal reasoning. Then there's often an argument that there must be learning in such a system, otherwise it's not a cognitive system. Then you must have an output. Other people solve it in a way that say, okay, somewhere in my system I use, for example, SOAR, which is a cognitive architecture. And as soon as you have one component which is cognitive, then the whole system becomes a cognitive system, and so I have done the job. And yeah, this is a problem that I'm facing in everyday discussion. Yeah, and especially in Germany. I think that cognition is a word nobody agrees on what it means. Yeah. And everybody wants to use it because maybe there's some money in using this word. So you would help me if you could tell me how can I defend my system? What do you think? When is the system cognitive?
Okay, no, I thought it was something else. So a general remark concerning the research situation in Germany concerning something.
Yeah.
So we have, for example, this actually this cluster Technical University in Berlin, in Munich, for example, it was cognitive system, something like that. This was not continued. This was closed. The Bielefeld program, which is also, they started this computer science program, that it was called cognitive computer science, or cognitive informatics. They have still the cluster, so this still exists. And there are some other programs that are not so much related, and then there may be something in Aachen and some other places really. Also, one of the first collaborative research projects in Saarbrücken, AI, for example, has the word cognitive in Saarbrücken and so on. In my opinion, and this is something where many people disagree, I never really was able to detect cognition in this cluster in Munich, because you had usually some hardcore roboticists. They were doing robotics before the cluster. They were doing robotics in the cluster, and now the cluster is finished, but they still do robotics. It was just a label because you can sell it perhaps. And this is a tendency that happens now quite often, in my opinion, because cognitive science programs grow, or programs that have this additional adjective cognitive grow, and they become more and more of them. And it's in so far politically just a label, I think, in order to sell something as new, which in fact isn't new at all. Okay, so now the hard question concerning what makes a system, artificial system, cognitive. So, okay, well, I had long debates with many people about some fine-grained distinction between a cognitive model, cognitive adequacy of a model, cognitive plausibility of a model, and the cognitive inspiration of it. And not all, and these things are usually not considered as co-extensional. So there are different meanings in the statement. Now the interesting thing is that people who claim that they have a cognitively adequate model, for example, claim that their model is cognitively adequate, where in my opinion there is nothing like that. So for example, Patrick Gentner and Ken Forbes call SME a cognitively adequate model in a very strong sense. Probably they would even make a claim that even ACT-R, for example, which is much more cognitive than SOAR, for example, ACT-R is not better in cognitive adequacy than SME. I'm pretty sure that they would claim this in public and defend this in any case. Although I don't believe that this is true. And therefore, we, for example, are extremely careful concerning it. I never understood what it means that a model is cognitively adequate. We call our model usually cognitively inspired, or in the best case, cognitively plausible, because we have some behavioral similarities between them, but we never, hopefully, in any paper claim that we have a real cognitive model in the adequacy sense. And I'm really relatively strict about it, because I just do not know what that should mean. So, and now coming to this lower level, which is not as a strong claim, I would say, so insofar as you can make relatively precise to which extent you, let's say, use cognitive mechanisms, cognitive principles, cognitive inspiration, or even if you want neurobiological inspiration or whatsoever, in order to build your model, I would, in any case, if this is clear and not completely a side thing, but a relatively central part, I would call your model definitely cognitively inspired. And this is how I would see it. I know that cognitive scientists usually have completely different opinions because they make extremely strong claims about that, and I never understood that.
I also had the experience that when I described what our program, our system should do, it was to just take a look at the current situation, then think about it, and then come up with a plan what to do next. And then the people would say, "Oh, this is really cognitive." And when I then explained, how it works, there is some A star, there is some graph, and then they would say, "Okay, now we can understand how it goes." It's not cognitive at all.
Yeah.
So maybe it's a black box, white box thing. When we don't understand what it does, when there's some magic in it, then there's cognition.
And actually one point, because besides this cognitive adequacy, plausibility, inspiration, and so on, there's clearly also a very important notion of a cognitive system. This is a very well established one. And in my interpretation, a cognitive system, if you interpret it in this loose sense that you just give a kind of a cognitive inspiration, then I would have not a problem to call your system a cognitive system, right? And this is the way I would interpret it. But I know that some people have different opinions.
Okay. So it's okay when it's from an outside view behaves like a cognitive system. It must not have some cognitive way of solving. So
what should that mean? So if there's a theorem proof behind the system, or there's a star algorithm behind the system, or somehow included in the system, or there's an artificial neural network in there, so what cognitive plausibility does that have? We do not do classical backpropagation in our brains, so the neural network is just an abstraction. We do not never an A-star search. It's just an overflow of our memory abilities. We are principally, in my opinion, and this was also one of the first slides, I think humans have fundamental problems to think like theorem provers compute something. Because in this formal domain, everybody who tried to prove something in a real calculus, like a theorem prover. So take a Hilbert calculus or a Jensen type calculus or some kind of proof calculus, and then try to write down by hand the proof. That's a disaster. Because we are just not working this way. It's just not what we can do. And therefore the plausibility for these things is far from being understandable.
Actually, this harkens back to the first few days of our summer school where we discussed sort of what would be the necessary but possibly not sufficient ingredients of an AGI system. I think these terms are vague enough that you can transfer mostly. You can use the terms as you wish, essentially, without losing too much meaning. But you may upset some groups who have a firmer definition of it. And ultimately, it's about the definition of concepts. So I don't think we should spend too much time on that. But it is an interesting, if you dig a little bit deeper, sort of, if some version of a G is what you want in your AGI system, what are the necessary and sufficient components to or functions to actually make it so? But we should maybe come back to that tomorrow. I wanted to ask one last question because I saw here an interesting one. It's about generalization. If your system is learning by generalizing things, how do you control this process of generalization? Should it continue to try to generalize and make analogies, forever and ever? And as we've established, you can always find similarities between anything and anything else.
Yeah.
And so, how long should you do that for, and why? And what's the point?
That's a good point concerning the general mentality. So clearly, and this has also a lot to do, I think, with this idea of lifelong learning somehow. Because so formally, technically, you can generalize everything. That's clear. So you can, in any case, also in this framework, for arbitrary inputs, you can compute a generalization that is then just a big capital X or so, that everything is covered in the substitutions, for example. But that's possible. But clearly that is not what you intend, because then you would say, well, that's way too much. So that's probably and clearly we don't have anything in this direction where we can control this in a long-term learning process. But I think, and this is again something I would like to test in the near future, I think that a good domain to test such things is again the semantic web machine. Because here you have an upper bound and a lower bound. The lower, the most specific bound is the large database with RDF tables, and the upper ontology level is some kind of, I don't know, the sumo or some of these upper level ontologies where you have only as concepts thing and on this level. And then there are these many things between, right? On arbitrary levels you can have some conceptual dependencies. And what I would do, and I talked to Tom van Harmelen, although we didn't start with it, but I would like to do it a little bit with his input from his large knowledge collider project. What I would like to have is to start with just these RDF triples of appropriate pre-chosen domain somehow where something fits to a certain extent together, right? And then you start to compute via generalizations a different level of representation of these things. And I could imagine that this type of data they have and this kind of ontology environment could be a good test phase precisely to address this question. So to which extent can you do this? And where will you get fundamental problems? And I guess we will get fundamental problems because usually the generalization processes are too fast generalized. And so I cannot give you an answer to that because we didn't do this yet, but I think this would be the right place to address precisely this, but in a controlled domain, rather than in a controlled domain. This was one of the discussions I had several times in the structural design.
Pei, have you done anything like that?
Yes. Actually, that's one advantage, I would say, of term logic over predicate logic. In predicate logic, if you have say, a ground level fact, okay, there are many levels of generalization you can go up. And the logic itself doesn't tell you anything about where to stop. So people typically use, say, heuristics or some kind of order, and so on. In term logic, the situation is not like that. In term logic, you always, again, that's the picture I draw, you always use two premises to derive one conclusion. As soon as those two premises are picked, selected, you can only derive one, well, of course, in two directions, you can get two of them. You don't get infinite number, okay? For example, if I see something happened to this laptop, then, for example, I see it can display a certain picture, okay? I can say this laptop can display that picture, or I can say, oh, MacBook Air can display that, or I can say, oh, laptop can do that, or I can say, oh, computer can do that, or I can say, oh, object can do that, okay? Where should I go if you're doing term logic? One premise will be, okay, this thing has a certain property. The second premise will be, this thing is what? Okay, if the second premise I picked is this thing is a laptop, then the conclusion will only be, oh, laptop can do that kind of thing. I'm not going to go further. So now the problem completely become the selection of evidence of premise in each inference lab. That is controlled by the control mechanism, depend on the activation, depend on, for example, one interesting issue is many people may assume, when you do generalization, you always start from the most specific, then you go up. That's not true, okay? For example, in this case, I typically will say, oh, this is what Macintosh does. I'm not going to say, this is a Macintosh of this size, of this shape, of this color will do that kind of, even though that is a more concrete concept than Macintosh in general, okay? So we have this thing that in cognitive psychology they call basic level concepts, which typically have a priority compared to the other things when you're talking about generalization or induction. If you're doing that in the framework of a term logic, all those kind of factors can be relatively natural to be combined together into say that if I want to generalize, what is the first concept that comes to my mind when I see this? I will say typically laptop, or some people will say Macintosh. Okay, that's kind of like a middle level concept. You don't go all the way, say, object to that level. Or something have a square shape, you don't go to that level. Okay. So it's relatively easier, but it's still easier, but it's relatively easier to control the level of generalization in term logic compared to predicate logic, because predicate logic, you basically come from one premise, in that case, to the conclusion. So that premise can be actually anywhere, logically speaking, in the hierarchy.
Well, I think there is two things. So one is really about the conceptual basis of the whole thing, that's the ontology somehow. And that's the term logic idea, essentially. And the other one are general rules that govern somehow a physical law. It's a complex rule, usually taking into account many different things, and it's not on the conceptual level that I have only, well, a car is a vehicle, for example. And there is actually, in computational linguistics and natural language processing, this is a very old problem. Assume now we don't want to compute generalizations, but assume you have an ontology. Right? And then you get textual input. You need somehow to map these things that appear in the text to the concepts, because that's something you want to know, because there's a word, chair, and then this should refer somehow to the concept chair. But there may be also some just in the text stated that the text is about BMW, and then the sentence says the car is in front of the house. And then, well, about what are we talking now? Because from the context it's clear that it's not the concept car, but it's a very individual of a car, namely this particular BMW that is in front of the door. It's also the case that about concepts usually it's hard to extract knowledge from text about concepts, because concepts as concepts do not appear quite often in texts. But if you want to learn something, the easiest way is to extract Wikipedia from the World Wide Web and just parse the first sentence. And most of the first sentences of Wikipedia, there's a definition of a concept. This is a good resource. But just an ordinary newspaper article just does not really contain many concepts. Right? Because it's about individuals, it's about Barack Obama, it's about this shot down airplane or this whatever, but it's not about the concept, president or the concept. And then there's another thing, and this makes it difficult in computational linguistics, and this is the mapping that was mentioned by P. Language is all the time, or most times, very strongly underdetermined, because you don't get the necessary information that is intended to give. You just get a certain glimpse or a little hint or so, and we do the rest somehow. And computational linguists precisely worked on this problem. If you have underdetermined situations, right, in the text, but how can I guarantee the mapping? How can I make word sense disambiguation? Why is it possible that something like Shakespeare wrote Romeo and Juliet, the tragedy took place in Verona also. So how is it possible? This is true, right? So okay. So how is it possible that the tragedy refers to a particular play by Shakespeare, which takes place fictionally takes place in Verona, and why is not tragedy referring to some disaster in Shakespeare's life, or some kind of disaster going on in the UK or so at that time? We immediately get the right interpretation of these things, and for computational physics this is really a problem, right? And for example, this PhD dissertation of Ekaterina Ovchinnikova was precisely addressing such problems, because these hundreds of thousands of axioms were just used, for example, also to make such things possible and to draw the right inferences from such things. And so computational linguistics was strongly concerned with finding the right concept where it refers to, right? On the right level, not too abstract, not too specific, on the right level. But here, and this is a little bit of a different question, but here you have already an ontology somehow, and this is a little bit a different question from the question I generate it automatically somehow and need somehow to learn the whole thing and somehow to stop and learn to know when it's too general and when it's too